All right, so for these two problems here, we're going to do binomial expansion. Now, you can use the binomial theorem, which is fine. Now, I'm going to use another technique using Pascal's triangle. Now, Pascal's triangle is just, it kind of incorporates the binomial theorem, but makes it much less complicated. And so, what is Pascal's triangle? Pascal's triangle is just something very, very simple. It starts out with a 1, and then the ones on the end, you just keep carrying down. And so, this is brand new, and it's just this Pascal's triangle just has a very unique pattern to it. I keep bringing down the ones on the outside, but then as soon as I have stuff to add, I start adding them. 1 and 1 give me 2. But I keep bringing down the ones. And then 1, bring it down, then 1 and 2 gives me 3. 2 and 1 gives me 3, and bring down the 1. And keep going. Bring down the 1. 1 and 3 gives you 4. 3 and 3 gives you 6. Oh, yeah, and then 3 and 1 gives you 4 again, and bring down the 1. And so what this represents is the extra coefficients for a binomial theorem, or for expanded binomials. This first row is actually a degree of 0. Second row is degree of 1, then degree of 2, degree of 3, degree of 4. All right, oh, there, degree of 4. We're going to need that one. So I'm going to put that underneath here to remind me. 1, 4, 6, 4, 1. All right, and now let's go one more because that one's a degree of 5, the first one. So we got to go one more for a degree of 5. And so we have 1. 1 and 4 give me 5. 4 and 6 give me 10. 6 and 4 give me 10. And 4 and 1 give me 5. And then you bring down the 1. Now, I didn't make a goof here, but I didn't make it very clear that I should put a little colon here. Here we go. All right. And so my extra coefficients for the 5th degree is 1, 5. So I'll write it underneath here. 1, 5, 10, 10, 5, and then 1. All right, so what in the world does all that mean? Well, here we go. So let's just clear this up here. Now, with the binomial expansion, the degree tells it everything. So this first one here has a degree of 5. And so to expand that, what you basically do is this. The first term I'm going to label as A. Second term is B. Okay. All right, and basically what you do is you have these extra coefficients, and so they'll follow. So it's 1A to the 5th, and then B to the 0. And we're going to follow this pattern the entire way here. So now, because there's a minus sign there, the signs will just simply alternate. That's all that means. And so I'll put the signs in a second. So let's see here. Next one would be, we have a 5. A to the 4th, B to the 1st. All right, so now I'll start putting the signs in. The reason why I wanted to wait is because I wanted to grab another color here. So that first sign was positive. Then it's going to be minus. Obviously, we don't have to write that positive. And let's just keep going here, right? So the next extra coefficient is 10. So that's going to be plus 10. And now the A is now going to get a 3. So A to the 3rd. And B is going to start going up. And we're going to look more closely at what this pattern is in a second here. Next coefficient is a 10. Oh, that's my mistake, because we have plus, minus. And then the coefficient is 10. All right, so A is at 3. That's got to be going down. So now it's going to be A to the 2nd. B is going to go up, B to the 3rd. Next extra coefficient of 5. I was minus, now it's plus 5. Now it's going to be just an A to the 1st and B to the 4th. Last one, change the sign, and it's just a 1 for a coefficient, A to the 0, and B to to the fifth. All right, so the reason why we alternated signs again is because on the inside over here, we had a minus sign. That's all. That's all that will do. And now we have all the placeholders. And we can start simplifying. And this first one is pretty easy because it's just an x and a 1. That makes this real easy. So anywhere I see an A, I'm going to put x. Anywhere I see a B, I'm going to put 1. So in this first one here, I don't actually have to write this 1 because 1 times anything is itself. And A is x, so it's going to be x to the fifth. And anything to the 0 power, this here, anything to the 0 power is also 1, so we don't have to rewrite that. Next, we have minus. Now 5, a to the fourth. Well, a is x, so it's x to the fourth. And now b to the first. Well, the thing is, b is only 1. And so because b is only 1, it makes it real easy. It's just 1 to the first power. And what I'm going to do here is I'm just going to use a different color. And I am going to put the, that's a bad color. I'm going to put the 1 right above the b. So that's b to the first, or 1 to the first, 1 to the second, 1 to the third, 1 to the fourth, and the last one is 1 to the fifth. Thing is, because it's a 1, it just makes it that easy. 1 to the first is 1, 1 to the second is 1, 1 to the third is 1. Those are all going to basically end up being 1s. And so b to the first power is just going to be 1. So now the second part here, it's going to be plus. Ooh, that's a bad plus sign. And so we have our 10. A is x, so x to the third. And again, the b is real simple. 1 squared is 1, and we don't really have to do anything to it. Because 1 times anything is itself. So now minus 10. Again, a is x squared. Again here, b to the third, 1 to the third, we don't have to actually write that. Plus 5x. Same for the b again, it's just 1. Minus, now a to the 0, that's x to the 0. A to the 0 power is 1. And so I just end up with 1 times 1 times 1, so that's just going to be minus 1. And so that's how you can easily and quickly expand this using Pascal's triangle. And this is, I think, a much easier and simpler way to do it than the Binomial Theorem. But now let's take a look at this one here, where there's something extra in front of the x, and this is something besides a 1. All right, and so let's clear up this a little bit. All right, so now this time the a is 3x, and the b is 2. But now we don't have to go as far because our exponent is 4. And since our exponent is 4, we're at the level above what this one was. So it's a little less complicated. And so this one here is going to be 1. And now since the degree is 4, that one will start with a 4. And then it's going to be b to the 0. And I'm just going to write the whole thing out just so we can see it again. Plus, now this one here, there's a plus sign. So that means they're all going to be plus. So plus, now it's going to be 4 a to the third. Remember, for this one, we're following this line here from Pascal's triangle. And it's going to be b to the first. And plus 6a squared. And then it's going to be b squared. And now next plus 4. And it's going to be a to the first and b to the third. And now last it's going to be plus 1 a to the fourth. And it's going to be b. Oh, back up. Sorry. It's going to be a to the 0, b to the fourth. Oof, there we go. And let's just verify the pattern real quick. So the a was at 4. Well, a is at 4, 3, 2, 1, 0. And the b was just the opposite. It started at 0, 0, 1, 2, 3, 4. Okay, we have the pattern. We have the extra coefficients. And so now it's time to plug it in. Now this time I'm going to plug in with parentheses because obviously if you look at it, it's more than just x. So I'm going to plug in with parentheses. I'm going to plug the whole thing in. So 3x to the fourth. I'm not going to skip any steps this time. And b is 2. That's going to be 2 to the 0. So I'm going to plug everything in. Okay. Plus, here we go. 4, and then again, a is 3x. That's going to be the third this time, times 2 to the first, plus 6, 3x to the second. And that's going to be 2 to the second this time, plus 4. And a, again, is 3x. And b, this is still 2 to the third, plus 1, 3x to the 0. And b, again, is just 2 to the 4. All right, let's make sure we don't have any little typos here or anything of that sort. It's not really typos, it's on a whiteboard. All right, so for the a's, we have 4, 3, 2, and then, I can write a 1. I don't have to actually write it, but I'll write it in. 1 and then 0. And then the b's, 0, 0, 1, 2, 3, 4. All right, now we can just start simplifying. And simplifying for this is not necessarily more complex, but it does a couple more steps. This 4 exponent goes to the 3 and the x. But the thing is, 1 times, I don't have to worry about this 1, because 1 times anything is itself. And the 2 to the 0, well, that's just simply 1 as well. So we're really just worried about this guy here. So I need 3 to the 4th and then x to the 4th. Well, 3 to the 4th is 4 times 4 times, I almost did it again. 3 times 3 times 3. And one more 3. So 3 to the 4th is 3 times 3 times 3 times, that's 81. Okay, I was just doing that on the side work there, that's all. And so just not confuse anyone, cleared it out. All right, so 3 to the 4th power, I almost did 4 to the 3rd. What a spaz, sorry, don't mind me. 3 to the 4th power is 81. And then it's x to the 4th. And remember that it's just 1 times 1. 2 to the 0 power is just 1. All right, so now let's keep going here. So it's plus. Now this time it's a little different because I have 4 times 3. So basically this 3 has got to go into the 3 and the x because that's how we have to make sure we substitute with parentheses. So 3 times 3 times 3. Let's just get the calculator real quick. All right, so we have 3 times 3 times 3. But now it's also times 4. 108. So this guy is going to be 108. And x to the 3rd. And now a lot of students, when I start writing this, half of them were like, oh, okay, that sounds right. But now the other half of students usually say, hey, whoa, wait a minute. What about this guy? Exactly. That's 2 to the 1st, which is 2. So it's not just 108. It's 108 times 2. And so we're at 216. And that's a very common mistake that I see students make. They'll completely forget about that too. All right, so here we go. Let's make sure we got this. So that's 216 x to the 3rd. And so to get to the 216, once again, we had 3 to the 3rd power, 3 times 3 times 3, times that extra coefficient, and then times the 2. So that's 216. All right, let's do the next one here. Since I have the calculator up already, let's do that. So here we go. So that's 3 to the 2nd power. So 3 times 3 times, this time we have a 6. And then, let's see here. Now we have 2 squared, which is 4. So times that by 4, we get 216. Oh, 216 again. And let's see here, let's look at the variable. That's x squared. X squared. Next, it's going to be plus. All right, so let's take a look at this multiplication here. So now here we have, now 3 to the 1st power. that's fine. So that's just 3. So 4 times 3 times, and that's 2 to the third power. So times 2 times 2 times 2. All right, so we got them all. 96. So we're at 96. Now that's just x to the first now. And last but not least, 1 times, well, this is actually 0 here. Anything to the 0 power is 1, so that's just going to be 1. 1 times 2 to the fourth. Oh, what is 2 to the fourth? Yikes. 2 risen to the fourth, 16. And so there we go. That binomial was expanded. And again, I just wanted to show you one where it was very simple. X minus 1 was to the fifth power. We used technically the sixth row of the Pascal's triangle, because remember the first row is 0. And this one was 4. And so we use the fifth row, remember again, because the first row is 0. And what I mean by that is, remember when we did the Pascal's triangle, 1, 1, 1, 2, 1, and so on. And, keep going down. Remember the first row is 0, degree is 0, 2, or 0, 1, 2, 3, and then 4. So that's where we got the extra coefficients. And we make sure we substitute them with parentheses this time. And so that would be your final answer down there. There's this guy right here. All simplified and ready to go. All right, this is a very tricky topic. So if it's confusing, just replay the video again. And if you're more comfortable with the binomial theorem, you go for it. That's okay. I just personally think it's a little more complex than what I presented here. So if you need any more questions, please let me know. I hope you have a good night.